Hello. Okay, so in last video we talked about what fundamental trigonometric identities are, and in this video we are going to talk about how do we apply them. I don't know if you can hear my dog making noise in the background, but he's drinking really loudly. Okay, anyways, so today we're going to kind of focus on these bottom three Pythagorean identities and how to apply them. So let's take a look at a problem here. It says, use the fundamental trig identities to find the exact value of the expression if pi over 2 is less than theta, which is less than pi. So this is radians, of course. So this is just a fancy way of saying that theta is somewhere in quadrant 2. Okay, so we need to keep that in mind when we get our answer. Just thinking about, just like we did a couple units ago, we have to see if our answer is going to be positive or negative based on what we get. So now it says if cosine of theta is equal to negative 4/7, find sine of theta. So we've done this a lot of different ways, but this time it says to use the fundamental trig identities. And so if I go up and look at these three, in the problem they have sine and cosine. So that's probably a pretty good indicator. I want to use maybe this one, okay, because it has sine and cosine in it. So we're going to apply that one or try that one and see if it works. So, right, it says cosine squared theta plus sine squared theta equals 1. So I'm just going to write that first. Okay, now we already know that cosine theta is negative 4/7. So I can say negative 4/7 squared, put it in parentheses, plus sine squared theta equals 1. Okay, so now if I just square negative 4/7, remember a negative times a negative is a positive, so this will become, and when you square, you're just going to square the top and the bottom. So this is going to become 16/49. This is still just sine squared theta equals 1. All right, now if I'm solving for sine squared theta, the first thing I have to do is subtract 16/49 from both sides. Okay, now when you do that, of course, this is going to cancel out, and I'm going to have sine squared theta equals, all right, so now when you're thinking about this, right, you want to write it, when we subtract or add fractions, we want a common denominator. So because the other one is 49 in the bottom, you want to think of this as 49/49. Okay, so if you take 49/49 minus 16/49, you end up with 33/49. Now, we have sine squared theta. Oops, I forgot this thing. There we go. So we need sine theta, though. So that means I need to take the square root of both sides. So I'm going to square root this side and square root this. Now remember, when you square root a fraction, you're really just taking the square root of both the top and the bottom. So the square root of 33 is not a nice number. It's the square root of 33. And you, just like when we did our radicals unit, you want to make sure that you can't break that down any further. You can't. 33 is a prime number, so that's as broken down as it can get. All right, and then the square root of 49 is 7. Okay, so this might be my answer. We just have to keep this in mind. It says that sine, it says we're in quadrant 2 for theta. So sine is y. So if we think about quadrant 2 in the unit circle, okay, or I guess just quadrant 2 right here, our y values are positive in the second quadrant. So that means my answer here should remain positive. So you want to double check. It might be negative, it might be positive. That's really what they're talking about when they're looking at this type of thing here. So that means my answer is sine theta is equal to the square root of 33 over 7, and it'd be the positive version, so we're just going to leave it there. Okay? So that's using a fundamental trig identity to find the exact value of in this case sine theta. Okay, let's try another one that's got a little bit more going on. It's slightly trickier, but still not too bad. Okay, so this one says use our fundamental trig identities to find the exact value, and this time it says, notice they give it to us in degrees rather than radians, but it says from 180 to 270. So again, that just means quadrant 3. So we're going to take a look at that. All right, so here we go. It says if cotangent of theta is equal to 2/5, find cosine of theta. Now, we have cotangent and cosine. So let's go up here. Okay, now I don't see, I have one that has cotangent in it right here, but there's no cosine. I have one that has cosine in it, but no cotangent. So what the heck do I do? So this is a little bit tricky. So again, cotangent and cosine. So you might have to look at how these are related maybe with the reciprocal ones. So this reciprocal one is tangent, and the reciprocal of cosine is secant. Okay, well, I don't have these two together, but if you look at these trig identities, I do have these two together right here. So I can't find anyone that puts these together, but that's okay because these are just reciprocals of each other. So if I can find their reciprocals together or every combination, I could still get there. So I want to use tangent squared theta plus 1 equals secant squared theta instead. So let's go back to our problem. So I'm going to write down that right now. It's tangent squared theta plus 1 is equal to secant squared theta. Okay, now before I start, I just want to lay out a couple of things. Now, I am given cotangent, so that means I can figure out what tangent is. If cotangent of theta is equal to 2/5, then that means tangent of theta is equal to 5/2. Okay, so we're going to start there. So now I can go and see if we can maybe get to figuring out what secant is, and then from there we should be able to figure out what cosine is. So this would be 5/2 squared plus 1 equals secant squared theta. All right, so squaring this, I get 25/4 plus 1. Okay, so now I got to take 25/4 plus 1. Well, we probably want to, if we're adding fractions, again, we want a common denominator. So another way to think of 1 is 4/4. So 25/4 plus 4/4 is 29/4. And that gives us secant squared theta. Okay, so now what we want to do is take the square root. Okay, so I'm going to write that over here. So secant theta is equal to, all right, the square root of top would be square root of 29. And the square root of the bottom would be 2. All right, so now I know what secant is, but notice they're asking for cosine. Well, again, the whole reason we went down this road is because secant and cosine are related. They're reciprocals of each other. So cosine theta is just the reciprocal of this. Okay. Now, once again, we have a radical in the denominator, so I have to fix that. In order to do that, I'm going to multiply by square root of 29 over square root of 29. And you should be pretty good at this by now. So that would give me 2 root 29 over 29. Now I want to see, can I reduce that at all? No. Okay, so the last thing I have to do is I have to go back to this quadrant 3. So cosine, remember, it is x, and in quadrant 3, cosine, or x, is negative. So I need to tack on a negative to this, my answer here. So this should be negative. So always at the end, check to see what quadrant you're in, and then determine if your answer should be positive or negative. That's really all this quadrant stuff means, or this, they're telling you when theta, where theta is. So in this particular case, we used a trig identity to find what the exact value of cosine theta, doing a little bit of math there. And we ended up with negative 2 root 29 over 29 for cosine theta. And that's it. All right, I hope that makes sense.